Hello. In this video, we're going to continue solving exponential equations, but we're going to make them progressively more difficult. Now, this first one's a nice warm-up. Remember, the basic idea here is we need to have a common base. 4 and 2 are not the same base, but 4 could be written as a power of 2. It's 2 squared. So if we write that as a power of 2, we then have to use some exponent rules. So this is 2 to the 3x. Here, the 2 multiplies on both of these. So we get 2 to the x plus 6. Now we have the same base here, 2, 2. So we get to drop the base or equate the exponents. And you get 3x equals 2x plus 6 minus 2x on both sides, x equals 6. And of course, if you wanted to check it, you don't have to, but just for fun, you could check it. 2 to the power of 3 times 6. That's going to be 2 to the power of 18, which if you have a calculator handy, 2 to the 18 is 262144. Over here you have 4 to the 6 plus 3, which is 4 to the 9. And 4 to the power of 9 is 262144. So yes, it checks out. But what if we had something like this? 16 to the 3x equals 2 to the 5x plus 2, 8 to the 2x. Notice that we have a 16, we have a 2, we have an 8. None of these are the same base. We have to somehow get them to all be the same base. So here, I think we could write 16 as 2 to the 4. Yeah, that sounds right. Maybe 2 then is going to be our go-to base. So 2 is already good, but the 8 we'll write as 2 cubed. Okay, so 2 to the 4, 2 cubed, and then we have to leave this 2 alone. It's already a 2. Here we got a 2x. Now we have to use those exponent rules, so power to a power, multiply. 4 times 3 is 12x. This is the same. This is 3 times 2x is 6x. Now you might say, oh, we have common base, we could drop the base. But if you look, you only have one term on this side, or one power, right? There's a base of 2, an exponent of 2x. Over here you have 2 of them. And so it's not really fair to equate the exponents or to drop the base, because if you thought about it, you're dropping one base on this side, but you're dropping 2 bases on this side. It's not really like balanced from an algebra perspective. And so if we want to drop the base, we have to have the 2's in common. And there's another step we have to do. When we're multiplying with the same base, then we get to add the exponents. So this becomes 5x plus 2 plus 6x. Now we have a single 2 on both sides. And so now we can drop the base. That's going to give us 12x equals 5x plus 2 plus 6x. But notice, we have to wait until we have a single power on each side. If you try to drop the base early, especially when there's 2 bases on one side and 1 on the other, it's just not going to work. It's going to get you into all sorts of trouble. But let's keep going here. We've got 12x equals 11x plus 2. So move the 11x over. X equals 2. All right. Let's try another one, and I would encourage you to pause the video and give this a try, see what you come up with. All right, so it looks like 6 squared is 36, and 6 cubed is 216. So we're looking at powers of 6 here. So we'll get a 6 squared, and a 6 cubed. Now that was our 36, so there's still a minus 3x. Still an x plus 3 here, and there's still an x outside. So we've replaced each one of these with a power of 6. 2 times negative 3 is negative 6, so 6 to the negative 6x. 6 to the 2x plus 6. 6 to the 3x. But again, just like before, even though we have the same base 6, we have two bases on this side and only one base on this side. So we can't drop the base until we have the same number of bases. You can't even have two on one side and two on the other. You have to have a single base on either side. So let's go ahead and use our exponent rules. Because we are dividing, right, this division right here means we're going to subtract. So 6 to the negative 6x minus 2x plus 6 equals 6 to the 3x. So now we can drop the base. That's going to give us negative 6x minus 2x minus 6, distributing that negative. So minus 8x minus 6 equals 3x, minus 6 equals 11x, so x equals negative 6 over 11. And again, like we've talked about before, you can have negative numbers as your answer, you can have fractions, it's not a big deal. Now let's try one like this. So again, I'll give you a hint. The hint is that you're looking for powers of 3. So 3 squared is 9. And 3 to the 4 is 81. But go ahead and pause the video and give this one a try. All right, so assuming you gave it a try, we'll have 3 squared for that 9. X plus 1, oh yikes. Okay, that's lots of powers there. Thankfully this is still a 3, but this is going to become 3 to the 4, negative x plus 2. Times 3 squared. So we replace the 9, the 81, and the 9. Now on the left, 3 to the 2x plus 2, so we multiply that 2. But we still have the 5 there. I guess I'll multiply the 4, so 3 to the negative 4x plus 8. Okay, well now we got to multiply again here, 3 to the 10x plus 10. And because these are all 3's, we can add the exponents. So x plus 1 minus 4x plus 8 plus 2. All right, now we can drop the base. So 10x plus 10 equals x plus 1 minus 4x. Plus 10. Let's put everything on the left side, so that'll be minus x plus 4x plus 4x minus 10. So that's going to be 13x equals 1. X equals 1 over 13. All right, here's an even tougher one. Again, I'm going to give you a hint that you're going for powers of 3, but getting it all down to eventually just a single base of 3 will be a little tricky. So pause the video and give it a try. All right, so the 27 is 3 cubed. And then we have 2x plus 4, and then we have, well, this giant power of 2 out here. Then we got a 3 squared for that 9, then a 2x plus 7. Over here we just have a 1/3 to the x minus 6. So everything's 3, but there's just so much going on here. I guess we'll just start on the inside. So we'll take that 3 and multiply it in. Take that 2 and multiply it in. 3 to the 6x plus 12. 3 to the 4x plus 14. Here I could write this as 3 to the negative 1 just to get rid of that fraction. Remember, 1 over 3 is 3 to the negative 1. Nice little exponent rule. I guess maybe I'll divide these exponents. So 3 to the 6x plus 12 minus 4x minus 14. But it's still square, that's annoying. Power to a power will multiply, so negative x, negative makes a plus 6. Maybe I'll clean up the exponents in here. 6x minus 4x is 2x. Negative 2 squared Okay, multiply again. 2 times 2 is 4, so 4x minus 4. Okay, finally I've got a single power on the left, a single power on the right. They're both base 3. So we drop the base and get 4x minus 4 equals negative x plus 6. Move the x over. 5x equals 10. Divide by 5, x equals 2. All right. So in terms of notes, we're mostly just working on harder and harder questions as we go through these. So we're still solving exponential equations. And the main thing we need to watch out for is if we have 3 to the 2 times 3 to the x equals 3 to the 4, we can't drop the base yet. Can't drop base until single base on either side. So now you get 3 to the 2 plus x equals 3 to the 4. And of course, the way we did that was exponent rules. We're going to need those. They come up all the time when solving exponential equations. Now, for an example here, let's say you had maybe 2 to the 3x times 4 to the 2x minus 1 times 8 to the 11 equals 1 over 16 to the x. Again, go ahead and solve for x. All right, assuming you give this a try, we're going to go for powers of 2. So that's just going to be 2 to the 3x. 4 is 2 squared. 8 is 2 cubed. And 16 is 2 to the 4. Now we get 2 to the 3x, 2 to the 4x minus 2, 2 to the 33 equals 1 over 2 to the 4x. All right, we can combine these. So 3x plus 4x minus 2 plus 33. And over here, we should make that negative, so 2 to the negative 4x. Now we can drop those drop the base and equate the exponents. And that'll be 7x plus 31 equals negative 4x. So 11x equals negative 31. X equals negative 31 over 11. You can try one on Unit 8, Worksheet number 2, and then write down any things to remember. All right, hopefully you enjoyed this video, and as always, thanks for watching.